Alright guys, I just got done recording the last video, which was going over a few of these factoring polynomial problems. And I want to do a few more. I think this is the video I did on the last problem, on the last video. So we're going to skip ahead to the next one. I want to do just a couple more with you because we need some practice. We really do. It's going to take a while to get this down. Alright, go back to your notes and look at the factoring order that we've talked about in the past. I'll go ahead and briefly show it to you on this screen, what I'm talking about. But this is my factoring order. I would take a picture of it, have it somewhere where it's right next to you as you're working. You can go through and look at what type of factoring you need to be looking for throughout some of these problems. Okay? So that's the one we just covered. Let's go ahead and let's just do a couple more of these together. Okay? I didn't want to add this to the last video because it would have made it too long. Alright, but here's some more practice. So, step 1, make sure everything is on one side and 0 is on the other. That is the case here. Everything is on the left and 0 is on the right. Step 2, always check for GCF. Do all three of these terms that I have on the left here, do they all have something in common that they can be divided by? And the answer is yes. These are all divisible by 2, right? 2, 10, and 12. They're all divisible by 2, but they also have x's. They each have at least 4 x's right next to the 4. So we're going to take all of that out. Alright, and that 2x to the 4th, do not forget that 2x to the 4th is still part of the problem. It is just now all the way in the front and out of the way. So let's fill in what we have remaining inside these parentheses. 2 divided by 2 is going to cancel, leave us 1. This will be left with x squared because 6x's take away 4 will be 2x's remaining. The second term, negative 10 divided by 2 will be a negative 5. 5 minus 4 will be 1x remaining. And then negative 12 divided by 2 is negative 6. And 4x's minus 4x's mean there's no x's remaining. Alright? So there it is. I've factored at least my GCF. Now I have 3 terms in my parentheses. And when I have 3 terms, I should look for product and sum. So product and sum is my x thing. Remember, we're going to put a times c at the top and the b value at the bottom. So here, my a is 1 because it's 1x squared. My b is negative 5 because negative 5x. And c is negative 6. So a times c, 1 times negative 6 is negative 6. My b value is negative 5. So I need to figure out what 2 numbers multiply to negative 6 and add to negative 5. So, again, if it multiplies to a negative, one number is positive, one number is negative, right? That's the only way I'm going to result in my product being negative 6, a negative number. So what do I multiply to 6? Well, 2 and 3 come to mind. So I can try that. Positive 2 and negative 3. But 2 minus 3 would be negative 1. So not negative 5. I think if you play around with this enough, I think it'll be a positive 1 and a negative 6. Because positive 1 times negative 6 is negative 6. But positive 1 minus 6 is also negative 5. So these are my results. And since a equals 1, these are also my factors. So I'll write this as 2x to the 4th, of course, and x plus 1 and x minus 6. Alright, again, these 2 numbers are just simply a result of my product and sum that I got there. Alright, so since all of this equals 0, I have to figure out for each piece what the x value is to equal 0. So for 2x to the 4th, that's going to leave me with x being equal to 0. For x plus 1, it's going to be x equal to negative 1. And for x minus 6, it's going to be x equal to 6. Okay, remember, how did I get those in case you're wondering? Because for x minus 6 equal to 0, if you were to solve it, you get x equal to positive 6. For x plus 1 equal to 0, if you were to solve it, you get x equal to negative 1. And for 2x to the 4th equal to 0, if you were to solve it, you will get x equal to 0. So, those are your roots, those are your solutions. Ta-da! Let's try some more. Okay. This one This one's a good one. All right, so first step, make sure everything is on one side and 0 is on the other. So here I've got 3 terms on the left, and I've got this negative 50 on the right. So first things first, let's move the negative 50 over there. Right, how are we going to do that? Well, since it's negative 50, we're going to go ahead and add 50. So that makes the left side x to the third minus 2x squared minus 25x plus 50. And then now it'll just be 0 on the right. Alright, so everything's on the other side. Step number 2, always check for a GCF. Do all 4 terms in this case, because I've got these 4 right here. Do all 4 terms have a common factor? Do they all have something in common that I can divide by? The answer is no. They can't all be divided by a number, and they don't all have x's. There's nothing in common between all 4. Alright, so GCF's not going to work. What else should I try? Well, since there are 4 terms, we should look to see if I can factor by grouping. And I think I can. I'm going to go ahead and put this on the left, or I'm sorry, the right side, so that I have a little bit more space. Alright, so when you factor by grouping, you group the first 2 terms together, you group the second pair of 2 terms together. Remember, since there's that minus, that minus sign here with negative 25, I have to make sure I include that minus sign in that group as part of that term. Alright, so the first group, both of these have 2 x's, or an x squared. I'll factor an x squared out. That'll leave me with 3 minus 2, would leave me with an x to the first. And these x's cancel, leaving me with a minus 2. The second group, I can divide both of these by 25, but more specifically negative 25. So negative 25 will come out. I'll be able to do x. And then 50 divided by negative 25 is negative 2. Alright, so it's working. Remember, every time you do difference of squares, every time you do factor by grouping, you should get common binomial factors. So you see both these groups have an x minus 2 in common. Bring that x minus 2 and set it aside. Alright, now what's left without the x minus 2s? X squared minus 25. Alright? However, I don't know if you're thinking this, but we are not done factoring this problem. Because now, these binomials. I know x minus 2 is not factorable. It's already as simple as it gets. However, x squared minus 25 is factorable. And if you look back at your 2 terms, if you have 2 terms, you should check for difference of squares or a sum or difference of cubes. Now I've got squares here. These are difference of squares. This is x squared minus 25. Now, these are easy enough if you remember how to do them. Go back to the factoring review video if you're not aware of how to do them. But this is x squared and this is 5 squared. So when they factor, it'll just be x plus 5 and x minus 5. So there you go. You got those 3. X minus 2, x plus 5, and x minus 5 as your factored result, which means that your x values are a positive 2, a negative 5, and a positive 5. Those are your solutions. Alright. Here's a power school question. This is really what I want to cover. So which is a 0 of the function f of x equals 2x squared minus x minus 3? What we should do here is factor and see what the answers are and see if any of those or which of those, A, B, C, or D, matches what I get in my answer. So, for 2x squared minus x minus 3, I've got 3 terms. I first want to check to see if there's a GCF, and there is not. But because there are 3 terms, we should try the product and sum method. So, the top goes A times C. A is going to be a 2, B is a negative 1, and C is a negative 3. So A times C, 2 times negative 3 is negative 6. B equals negative 1. What 2 numbers multiply to negative 6 add to negative 1? I'll save us some trouble here. I think it's negative 3 and positive 2. Now, what we haven't covered, in at least the problems we've done recently, is this is not a equals 1, right? A equals 2, which means I can't just, these are not my factors. These are my x terms that I have to put back into my equation before solving. So this is a long way to go about this process. We've been using the shortcut, but remember, go back to the factoring review video if you're wondering what I'm talking about here. But for this one, because a is not equal to 1, I'm going to use these as x values, and I'm going to replace this middle x value with these two. So this will become, it was 2x squared minus x minus 3, right? But now I'm going to replace this middle term with my negative 3x plus 2x. The factors I got from here. And once I replace them, then I factor by grouping them. So when I group the first group together, I have a GCF. They both have an x in common, so I'll factor an x out. And that'll leave me with 2x minus 3. And now my second group, there is no GCF. There's nothing in common between these two terms, 2x and minus 3. So they stay the same. I can't really change anything about it. Okay? However, though, you do recognize the fact that when we factor by grouping, we get two common binomials. In this case, I have 2x minus 3. So we take the 2x minus 3 out, set it aside, move them. Now what's left without it? Now there's a bit of a catch here. Hopefully you see it. There's x, and then there's plus 1. You don't see the 1 there, but you have to kind of remember that it is there. Okay. And that's, if you want to think of it like this, you can divide both these terms by 1, and the 1 comes out, right, making the plus 1 there. Alright? And there are your factors. But now you want to know what the solutions are. So you have x plus 1 equal to 0. So when you solve for that x, you're going to have x equal to negative 1, which is not one of my answer choices. So let's try together. 2x minus 3 equals 0. Let's solve for x. We add 3 to both sides. We have 2x equals 3. Dividing by 2, we're going to get x equal to 3 halves, which is an answer. So my answer would have been B. So it's asking you to do a lot here. It is just factoring a little bit by product and sum, but you do want to make sure you get your answer at the very end. So the solutions to that one would be negative 1 and 3 halves. It's asking which of these 4 answer choices is one of the answers, and of course, 3 halves is it. So for my next trick, which function has the zeros of 1 and negative 3? So the second question would be really easy on a graphing calculator, because you can just graph each of these, A, B, C, and D, and see which of them cross the x-axis at 1 and negative 3. But without doing that, you have to do it the old-fashioned way of product and sum. So since A is equal to 1 in all of these, that means, all right, actually, here's a better way of doing it. Rather than factoring all 4, we'll just reverse engineer this. If the zeros are 1 and negative 3, that means I've got x minus 1 as a factor and x plus 3 as a factor. Because remember, these are kind of opposite signs. So if those two are factors, and if I multiply them together, I'll get one of those results. So let's FOIL these. X times x will be x squared. X times 3 will be 3x. Negative 1 times x will be negative x. Negative 1 times 3 will be negative 3. And these are like terms here in the middle. 3x minus x would be 2x. And I've got my answer. X squared plus 2x minus 3, or A. So that's tricky. I could have factored all 4 of those and saw which ones got me 1 and negative 3, but I figured I'm smart enough to recognize that, well, I can work this backwards. If it's telling me the answer, then I'll work from that on up and see what I get. So the catch is to remember that the zeros are opposites. So my 0 is 1 and negative 3. That means, as I said, that these would be x minus 1 and x plus 3 as your factors. Because remember, if you were to take those and equal them to 0, this is how you would get x equal to 1, and this is how you would get x equal to negative 3. Okay? So it's opposites of those signs, x minus 1 and x plus 3, but multiplying those together, that would be my answer. So it's kind of a tricky way of getting it, but nonetheless. What are the linear factors of this one? So, same as before, just factoring. It's all just a bunch of factoring. Alright, so I've got 3 terms. Again, I'm going to ignore my equal 0, just kind of distracting at this point. But these 3 terms, I always should check for a GCF. There is one. All 3 of these have an x. So I'm going to go ahead and factor an x out. So that x will come out, leaving me with x squared plus x minus 6. Alright, now immediately, since I realize I have an x on the outside, I know D is not an answer because there is no x on the outside. Of course, you see A, B, and C do have that x on the outside. It's definitely one of those. It's not D, though, because of that. So don't forget that that x is out there, okay? Now I've got 3 terms in the middle here, and when I have 3 terms, I should try product and sum. So, A is equal to 1, B is equal to 1, C is equal to negative 6. So A times C, 1 times negative 6 is negative 6. My B value is 1. What 2 numbers multiply to negative 6? Add to 1. Now we venture to say 3 and negative 2. 3 times negative 2 is negative 6. 3 minus 2 is 1. And because A equals 1, these are indeed my factors, meaning that this would become x plus 3 and x minus 2. But again, don't forget that this x is on the outside here. So my answer is B. Ta-da! Alright, I think what they're going to do is they're trying to trick you. I recognize now what they're doing in this problem. Because B and D are very similar, right? They both have x plus 3 and x minus 2. They're going to assume that you forget that you factored this out. They're going to assume that you factored it out and threw it away and you didn't keep it. If you forget that this is on the outside, this x is on the outside, then you're going to say D is the answer. Of course it's not. So remember, whenever you factor GCF, that GCF is always out here, lingering around. It doesn't disappear completely. It's always a part of the problem. But we don't have to use it in any additional factoring, which is good. Alright, but don't forget that it's still there. Because that's the difference between getting this problem right and getting this problem wrong. Alright, let's see if there's anything else I really want to cover. I don't think there is. At least with this video. I'll leave you guys at that. We'll, see you in the next one. Sayonara.